Hello, my name is Brandon Johnson. I'm a senior solution architect at Red Hat. Today, though, I'm going to present on an open source virtualization project that I am very passionate about, oVIrt. oVIrt is the upstream open source project to Red Hat virtualization, and I've had the pleasure of working with this product with my customers for over 8 years. You can find more information about oVIrt at oVIrt.org or Red Hat Virtualization at redhat.com. You can also find more information on my blog at open-tech.net. If you have more specific questions, please feel free to email me or reach out to me on Twitter or Telegram. oVIrt is a management solution for managing KVM, and it utilizes several other open source projects: Ansible for automation, Spice for VM console access, libguestfs for manipulating virtual disks, and Patternfly for its UI/UX design elements. oVIrt is designed to be scalable and has a flexible deployment model. Automation is a first-class citizen for managing and maintaining the platform, and it has built-in capabilities that are huge cost uplifts with proprietary competitors, such as resource scheduling and balancing, security, HA and DR, and software-defined networking. Today, we are going to focus on the deployment models of oVIrt and demonstrate how to install a simple environment. There are two deployment models for the hypervisor. You can choose to either install an oVIrt node, also known as RevH in the product, or a full Linux installation. The oVIrt node is a lightweight hypervisor that is based on enterprise Linux. It has a low storage footprint and is fully configured to run virtual machines, and it's managed by the cockpit web interface. The full hypervisor is either a full RHEL or CentOS node that has a larger storage requirement, but it's more flexible. The Rev Manager, or the oVIrt engine, will configure the host for use for virtual machines. And if you want to manage the host with the cockpit web interface, you will need to install it and configure that manually. When deploying the oVIrt engine or the Rev Manager, you have two deployment options. First is a standalone deployment, which means the oVIrt engine is running on a bare metal system or an external virtualization infrastructure. HA will need to be configured manually when using this model. The hosted engine deployment is my preferred method of installation. This method installs the oVIrt engine as a virtual machine in the environment it will manage. HA is handled automatically, and this greatly reduces your hardware footprint, so there's less to manage. Now, let's jump into the oVIrt deployment. For this demonstration, I have already installed the oVIrt node image. If you've ever installed Fedora, CentOS, or RHEL, it should be pretty familiar. After you install the oVIrt node, open a web browser and go to the cockpit interface to begin the installation. After you log into Cockpit, it'll automatically take you to the installation page. You'll notice two options: the hosted engine deployment, which we'll be doing today, and hyperconverged deployment. The hyperconverged deployment will configure the disks on your host for virtual machine storage using GlusterFS. I will create another video demonstrating the installation of that deployment model at a later date. For the hosted engine deployment, you will need storage pre-configured, such as NFS, iSCSI, Fiber Channel, or a POSIX network file system, such as Gluster. Let's go ahead and get started. The oVIrt hosted engine virtual machine is going to need a few prerequisites, one of which is a fully qualified domain name. For this demo, I configured a free IPA server to provide DNS services as well as authentication services for this environment. I already pre-configured DNS with the FQDN and the IP address that I want to use. So I'm going to set the FQDN. I'm going to set the IP address statically. And I'm going to add my free IPA as the DNS server. I could change the bridge interface. I'll leave that for defaults. I'm going to set a secure root password. Leave root SSH access enabled for the oVIrt engine. I'm going to set the memory to 4 gigabytes since this environment has limited resources. Normally I'd set that to 16 gigabytes or higher. Under advanced options, you can provide an SSH public key. Set the option to set the host file if you don't have a DNS server. But I usually leave this configured. You can also change the hypervisor host name, the default gateway address, and set an OpenSCAP profile for highly secure environments. I will be keeping all the defaults. In the next screen, it'll ask me some additional oVIrt engine specific configuration, such as setting the admin password for the administration console and email notification settings. I'll be leaving these at the defaults. Before we begin the deployment, let's verify the configuration. Everything looks good, so let's move on to the next step. In the Prepare VM phase, the oVIrt installation will configure the oVIrt engine VM with all the parameters we just specified. This will take several minutes to complete. Now that the oVIrt engine VM has been configured, we can now set up our NFS storage that'll be utilized in the oVIrt environment. So here we'll specify our storage type. As you can see, we can specify basically any type of storage: NFS, iSCSI, Fiber Channel, and Gluster. Here I'll specify the storage connection, in this case our NFS export. Also specify any mount options. In this example, there are none. Under the advanced section, we can specify a disk size for the oVIrt engine. In a production environment, I would set this to well over 100 gigs. I can also change the storage domain name for the storage we're using, and that's how it's presented in the oVIrt engine administration console. We'll take a look at the storage configuration. Everything looks good. Let's go ahead and finish this deployment up. In this last stage, this will configure the storage so it can be used by oVIrt, and it will move the oVIrt engine virtual machine to the NFS storage. This will take several minutes depending on your network speed, and when this is done, we will go look at the completed environment. Now that the installation is completed, let's move over to the oVIrt engine admin portal. In this section of the demo, we are going to add an additional host to the oVIrt cluster and provision a virtual machine, and go over some basic functionality inside of the oVIrt administration console. So this is the oVIrt landing page. When you first land here, you'll notice a few things. One is some documentation, the other is some download links, including an Android application that allows you to manage your oVIrt environment from a smartphone. But the link that you're going to want to pay the most attention to is the administration portal. The other link here below is a VM portal. The VM portal is an end-user self-service portal, And I will demonstrate that in another video. So let's log into the administration portal using the credentials that we provided at installation time. So you're going to land right here on a dashboard. This dashboard gives us a high-level overview of what's going on in our cluster. I can also see the resources that are available in this environment, as well as events, and we'll go into those later. So let's go ahead and add an additional host into the environment. So this host was already added at installation time, and we can see with this indicator that it's currently running the hosted engine. I can see that it's up. I can see that it's running one virtual machine, which is the hosted engine, as well as the current memory, CPU, and network utilization. Now, I've already provisioned an oVIrt node for the second hypervisor for this environment, so let's go ahead and add that. So first I'm going to give it a name, and I usually make this name the same as the host name, but this could be whatever you want it to be. The host name can be the DNS name or the IP address of the host. And if I'm using a non-standard SSH port, I need to change the SSH port, and I need to provide it with root credentials. And I can either give it a password or an SSH key. The other thing I want to be able to do is I want this host to be able to run the hosted engine. So I'm going to tell the oVIrt engine to deploy that capability onto this host. And this is going to give me a warning that I have not configured power management for this host. That's because this host does not have power management capabilities. So I'm going to click OK. And it's going to start installing this host and adding it to my cluster. While this host is deploying, I want to talk about storage. Storage is divided up into three main areas. Disks, which are the virtual disks or ISOs that you can use in your environment. Volumes, which is for Gluster. We are not using Gluster in this environment, so we're going to ignore that tab. And then domains. Domains are the actual physical storage that you're using in this environment. So first, let's go take a look at disks. Disks are the virtual disks as well as ISOs. So we can take a look at what type of disks are here and what they're attached to. There's also some other disks in here that were created at installation time that contain metadata and other information for the hosted engine to be aware of where everything is. I can also upload disks in this page. I can also download disks of virtual machines if I wish. I can also create virtual disks without attaching them to a virtual machine right away. Domains, as I mentioned, are the physical storage that you're actually using. There are currently two storage domains in this environment. The first one is the hosted engine, the hosted storage that was provisioned when we installed the hosted engine. This is an NFS-backed data store. And then the other one was attached at installation time as well. This is a public oVIrt image repository that is based on OpenStack Glance. And this has hundreds of images that you can use if you wish. There are other types of domains as well, not just data domains. The other type of domain is an ISO domain. I actually use this in other environments. The ISO domain is just a great way of separating out your virtual disks and your ISOs. The export domain that I used to use pretty heavily, and I don't really use anymore since that functionality has been rolled into the standard data domain, is really it should be called an import-export domain, since the export domain allows you to import virtual machines into the environment as well as export them out. Now, I'm going to add an ISO domain into this environment. An ISO domain can be an NFS storage, a POSIX compliant file storage, or GlusterFS. This is a NFS-backed data store, and I'm going to go ahead and add this to the environment. So I need to go into here and actually attach it to the environment as soon as it is activated. So you can see it's still locked. This will just take a minute. All right, now that it's activated, I can actually use this ISO domain, and I have several ISO images that I can use to deploy virtual machines into this environment. So let's go take a look at the host we just added to the cluster. It was added successfully, and we can see with this grayed out crown indicator that it can run an oVIrt engine. Now let's go deploy our first virtual machine. So this is the virtual machine screen, and there are several indicators here, very similar to the host indicator. I can get the current status of my virtual machine at a glance. I can also create a snapshot. I can migrate this VM. What this will do is it will allow me to live migrate a virtual machine from one host to another, or from one storage source to another. I can also do all the power functions that you would expect. Now let's go ahead and create our first virtual machine. So I'm going to give this virtual machine a name. I can specify an operating system, but you don't need to. For fun, I'll go ahead and just select Red Hat Enterprise Linux 8. I can select an instance type, and what this does is it will automatically configure the resources that are assigned to this virtual machine. But I'm going to go ahead and leave that at custom. There are other things you can do here, such as add a description, any comments. I can also specify that this virtual machine is stateless. This isn't exactly very useful when you're first creating a virtual machine, but it is really useful for VDI use cases, especially kiosk use cases. I can also add delete protection. So delete protection will prevent someone from deleting this virtual machine without first going into this virtual machine and unselecting this option. So the important part here is I need to add a VNIC profile. So this virtual machine will have storage. I also need to attach a virtual disk. So this will create a virtual disk of 20 gigabytes. I'm going to leave the default interface, and since this is the only storage domain available, I will use that storage domain. I will also then provision the disk. Now there's some other options in here. Let's go through them. The System tab allows me to modify the memory, the maximum memory, and the physical memory guaranteed, as well as the virtual CPUs. Now, what does this mean? This is the actual allocated memory for this virtual machine. The maximum memory tells me that this is the amount of memory that I can hot add to this virtual machine. And the physical memory guaranteed tells me that this is the amount of memory that is guaranteed on the physical host for this virtual machine. Under console, I can specify a different graphics protocol. I usually leave this at Spice and VNC, but I'll get into all these options in another demo. I can also specify what host I want this running on. I can also select if I want this machine to be highly available. Now what this does is it tells the oVIrt engine that it needs to reserve space for this virtual machine on another host, so that if a host fails, it'll restart that virtual machine on another host. And then another important one in here are affinity labels. Affinity labels basically tell the oVIrt engine not to allow one virtual machine that conflicts with another. So if you have two virtual machines that cannot run on the same host, you will need to apply an affinity rule to this. Now let's go ahead and click OK. And now we have our first VM. Now we need to install an operating system on it. To do that, I usually select this one runs option. Once I do that, I can specify that I want to attach a virtual CD-ROM, and I'm going to select the CentOS Stream ISO. I can also say I want to start this in pause mode, but I don't want to do that. I just want to change. I might want to change the boot sequence so it immediately boots into the ISO. And I can also specify other options as well. And I'm going to tell it to roll back this configuration after the reboot. So I'm going to hit OK. The virtual machine will start up, and then we're going to access the console. To access this console, you will need to install the remote viewer. So I'm going to install this virtual machine, and we will come back and we will look at this virtual machine, and I will also update it, and then we will prepare it to become a template. Now that my VM is finished updating, let's go ahead and create a template based on this virtual machine. Now there are a couple ways I can do this. I can select this VM and turn it off, go over here and select Make Template. That's not the way I like to do it. I like to use snapshots to create templates. So go ahead and go in and create a snapshot. I never save the memory when I'm creating a snapshot for a template. So let's go ahead and create the snapshot for our template. So this will take a minute. All right, now that that is done, we can go ahead and make our template. So to make a template, just click the Make Template button, give it a name. I could add a description, I could add some comments to it. And if I had additional templates, I could create a subversion of that template. This is great for virtual desktop infrastructure using pools, and I'll get into that in the next tutorial. And I can change the permissions for the template, copy the VM permissions if they're different than global, and I can also seal the template. Sealing templates is not yet supported on RHEL or CentOS 8. It's only supported on CentOS 7 and lower, or RHEL 7 and lower. So I'm not going to select this option. So I'm going to go ahead and create the template based on this snapshot. while that snapshot is being created, let's go over and take a look at the snapshot at the template page. So my new template is being created. I'll be ready in just a moment. Now, I can add templates into my environment in a couple of ways, not just by creating my own custom templates like I'm doing now, but I could also import templates through other means. So if I can place an OVA in the export domain that I mentioned earlier and import it into the oVIrt environment, or I can upload an OVA to one of my hypervisors. Usually I upload these into the temp directory, and then I will import them into the oVIrt environment. I don't have an OVA ready, so I'm just going to cancel this and wait for this template to finish. It should only be another minute. All right, that template just finished. So let's go ahead and build a new virtual machine. Before I do that, if I wanted to share this template, I could export this template. I could either export it to an export domain if I had one available, or I could export it as an OVA. Now, if I export it as an OVA, it's going to write that to one of my hypervisors. Right now, I don't have the storage to do that, so I'm going to just provision a new virtual machine. So let's go ahead and give this virtual machine a name. oVIrt VM2. Satisfied with all these defaults. I don't need to add a disk because it's just going to clone the template disk, the exact same size. Go over to virtual machines. Great. Now this will take a minute to provision. Now another way we can provision templates is by, provisioning virtual machines is by cloning a snapshot. Let's go back to oVIrt VM1 and create a virtual machine based on the snapshot we created earlier. So I just go into oVIrt VM1, go to snapshots, select the template snapshot, select clone. Hit OK. Now I'll have another virtual machine based on that snapshot here in a minute. So in this tutorial, you learned how to install a basic oVIrt cluster. I also showed you how to install and configure a virtual machine. And I showed you how to create a template and clone a virtual machine from a snapshot. I thank you very much for your time. Please let me know how you like this video, and I'll be creating additional tutorials around oVIrt and other open source projects here in the near future. Thank you.